A monomial, the prefix mono, like the illness, means one. So a monomial is one term. For example, if I had a polynomial, f of x equals 2x to the fourth, and it was just that one term, that would be called a monomial. A polynomial, poly means many, or more specifically, just more than one. So a polynomial has many terms. So something like negative 2x to the fifth plus 7x to the third minus 2x squared. I'm totally making up numbers here, so you don't even need to write the same numbers. Yeah. That polynomial definitely has many terms. What I did, I wrote this polynomial in standard form. So standard form means you start with the term that has the largest exponent, and then notice the other exponents that I wrote. X to the fifth, then the next biggest is x to the third, the next biggest is x squared, and then x, and then the number. So standard form is the term with the largest exponent first, and then the exponents are in decreasing order. Leading coefficient. If you know what the term coefficient means, leading coefficient is really not a difficult term to understand. Coefficients are the numbers in front of the variables. So in that polynomial that I wrote, negative 2, 7, negative 2, 10, and negative 7, those are the coefficients. So if your polynomial is written in standard form, the leading coefficient would be the first coefficient. The coefficient, the number in front of the term that has the largest exponent. So this is the number in front of the term with the largest exponent. Next, we're going to talk about the degree and the type of the function. The degree is the largest exponent. So above degree, you may want to write largest exponent. So in this example, the degree is 5, and the leading coefficient is negative 2. That's something that we're going to be talking about quite a bit, is the degree and the leading coefficient. In this table, it shows you a couple different types of polynomials. I'm going to start at the bottom with a fourth degree polynomial. A fourth degree polynomial has x to the fourth. The 4 is the largest exponent, and it's called a quartic. 4 quartic. Think about there's 4 quarters in a dollar, so quartic. A 3 as the degree, the largest exponent is 3, that would be a cubic function. If the largest exponent is 2, that's a quadratic function. If the largest exponent is 1, think about 5x minus 7. There is an exponent of 1 on that x. We just don't write exponents of 1. So if the largest exponent is a 1, it's linear. If the largest exponent is 0, that basically means there are no x's. There are 0 x's in that function. This particular example constantly has a value of negative 14. This function is constantly negative 14, so it's called a constant function. In example 1, we need to decide if the function is a polynomial or not. In order for it to be a polynomial, it needs to have real number coefficients. and positive real number exponents. So really, in a few of these examples, I'm going to show you when it is not a polynomial based on when it doesn't have those things. So in example A, is it a polynomial? 5, -2, and 8, those are all real numbers. The exponents are 1 and 3, those are all positive real numbers. So yes, this is a polynomial. Next, we need to rewrite the polynomial in standard form. Which term should come first? -2x to the third. And then we would do plus 5x and then plus 8 at the end. So we wrote it in standard form. Now we need to state the degree, the type, and the leading coefficient. So the degree, what's the largest exponent? 3. The type would be cubic. And the leading coefficient, the number in front of the term that has the exponent of 3, -2. And the first few problems on your assignment are simply just like that. Is it a polynomial, yes or no? If it is, write it in standard form, state the degree, type, and leading coefficient. How about B? Is B a polynomial? I hear some yeses. I hear some no's. Okay, question. Is the square root of 2 a real number? Can you punch the square root of 2 into your calculator? And you get a decimal. Is a decimal a real number? Yeah. The square root of 2 is a real number. The square root of -2 is not a real number. So square root of 2, that's definitely a real number. We don't usually see it in a polynomial, but it really truly is just fine. So yes, this is a polynomial. Standard form. Square root of 2, notice that that does not extend beyond the 2. That square root ends right after the 2. Times x to the 4th minus 0.8x to the 3rd minus 12. What's the degree? 4. And that means the type is quartic. That's a fun word. And the leading coefficient is the square root of 2. Okay, C. Is C a polynomial? No, because you have a -1 as an exponent. You have to have positive real number exponents. How about D? Is D a polynomial? Because you got x as an exponent, and x is your variable. We don't know what x is. So x could be a positive real number, or it could be the square root of -27. We don't know, and since we don't know, it can't be a polynomial. Do we need to do any more of these? No, we're good. Next page. We are going to evaluate polynomials for the given values of x. Now, at this point, I should give you a lecture about PEMDAS and making sure that you do math in the correct order. Instead, because this is Algebra 2 and you all at least have a scientific calculator, if not a graphing calculator, I'm going to lecture you about parentheses. Parentheses are your friend. You love parentheses. You love them very, very much. So everywhere that you see an x, directly around the x, you want to put parentheses. It's really important when you're plugging in negative numbers, but it's good just to get in the habit of doing this. So in the calculator, we're going to do 2 parentheses 3, closure parentheses raised to the 4th, minus 8 parentheses 3 raised to the 2nd, plus 5 parentheses 3 minus 7. To raise something to the fourth, you're looking for the caret button. I don't really know why we call it a caret button, but it's called a caret button. Basically, it's like an upward arrow. You're shoving the cursor up into the exponent area. Some calculators have something that looks like y to the x as the exponent button. Let me know if you need help finding or using your exponent button. If you are using a fairly new graphing calculator, there is a weird little quirk. When you punch in 2 parentheses 3, close your parentheses, caret button 4, it's going to leave your cursor up in the exponent. You have to hit the right arrow to bring your cursor back down out of the exponent. So just keep that in mind. So take a minute, punch this into your calculator, let's see what you get. On example 2a, you should get 98 if you plugged it into your calculator correctly. Now here's the thing. If you were to enter this in your calculator without parentheses, 5. Is 25 the same as 121? Definitely that you use parentheses. Parentheses are your friend. The degree and the leading coefficient determine what the ends of the graph is going to look like. So first let's talk about when your leading coefficient is positive. So the left side of this little chart. If your leading coefficient is positive, like this one might be positive 2x to the third, this one might be 2x to the fourth. If your leading coefficient is positive, notice what's happening on the right side of this graph. The graph is going upward. Now, if the degree is odd, so if the largest exponent is a 3 or a 5 or a 7, the other end goes the opposite direction. Odd, opposite. The other end will do the opposite thing. If the degree is even, like 2, 4, 6, 8, whatever, then the other side does the same thing. Now look over when the leading coefficient is negative, like if we had negative 2x to the third, and negative 2x to the fourth. If your leading coefficient is negative, the right side of the graph goes downward. If the degree is odd, the other side goes the opposite direction. If the degree is even, the other side does the same thing. In example A, our degree is 4. Is 4 an odd number or an even number? Even. That means the two ends are going to go in the same direction, both up or both down. The leading coefficient is negative 0.5. That's definitely a negative number. So the right side will point downward, and because the degree is even, the left side will do the same thing. Now, something's going to happen in the middle to connect these two arrows, but right now we don't care about the middle. We only care about the ends. On the next one, the degree is 3. Is 3 an odd or an even number? Odd. So that means the two ends are going to point in opposite directions, one up, one down. What's the leading coefficient on this one? Positive 0.25. Since the leading coefficient is positive, the right side will go up. Because the degree is odd, the left side will go the opposite direction. Odd, opposite. Okay, the leading coefficient always affects the right side. Now, in example 4, this is like test prep. If I gave you a graph like this and 4 possible polynomials as a multiple choice test, could you figure out which polynomial goes with this function simply based on the end behavior? So in A, it looks like the degree must be odd because they point in opposite directions. The right side points up, so the leading coefficient must be positive. Even degree because they point in the same direction. Right side points down, so negative leading coefficient.